Okay, guys, so we're going to be graphing sine and cosine today, just our parent functions with some vertical transformations or some stretches and shrinks, and just going over how we would graph the sine and cosine. So now on the x-axis, we're going to have our degrees, or sometimes you'll see radians if you use your calculator, but I'm going to do degrees here. And then the y-axis would be the actual sine and cosine values. So check out the charts here. And notice I just have 0, 90 degrees, 180 degrees. So those are, excuse me, only those quadrantal angles or the points that fall on the axis. So I'm going to go around my unit circle up here and just label these points. This would be 1, 0, 0, 1, -1, 0, and 0, -1. And if you remember from our previous lessons, the x is our cosine and the y is our sine, right? Because really cosine is equal to x over r, and x is always 1, and sine is equal to y over r, and r is always 1. So we're just taking essentially the x coordinate or the y coordinate for all the spots we want. So let's fill out our sine right here. So at 0 degrees, which would be this first point over here for our angle, right? 0 degrees. Our sine coordinate is 0. At 90 degrees, our sine coordinate is 1. At 180, our coordinate is 0. And at 270, our coordinate is -1. After that, I go right back to the beginning. So 360, I'm going to be 0. 450 would be up where 90 is, going to be 1. And then this pattern just keeps repeating over and over again as we go around the circle. So I'm going to graph these xy values on this grid over here for sine. And sine, I'm going to kind of write a little, I don't know, mnemonic device over here. I'm going to say sine starts on the spot. And think about like the spot, what I'm referring to is the origin, 0, 0. This is a quick way to remember the difference between sine and cosine. So 0, 0, I got my first point graphed. 90 degrees, so pick however far you want to go for 90 degrees. I'll go like 2 little lines, and this will be 90 degrees for me. 90 degrees, we're going to be up at 1, and that is the highest point on our graph. So on my graph, I will just keep the y-axis the same. I'll say this is 1, and I'm going to go up to 1. Then I'm going to go to 180, and I go back to 0. So back to what we call our midline, which right now is the x-axis. I'm going to write on here midline. All right. At 270, we're at -1. So again, I went every 2, so this would be 270. I'm at -1. And then 360, I'm back to 0. So we have this pattern. I'm going up to the tallest point, our mountain, back to the midline, down to the lowest point, I call it the valley, and then back to the midline. And if we kept graphing, I would just keep this pattern going. So every 2 lines, I would go up to the top, and then I'm going back to the midline, and then down to the bottom. I think about it kind of like a Loch Ness monster, you know, in the ocean, whatever our Loch Ness monster would look like. All right, so that's our sine curve. I'll even put a point over here, right? If we're at the midline, we're going down to the valley. And it goes on forever in this pattern. So on this graph, we're going to use it to think about some old measurements we would have. Domain are what are the possible x values. And our domain for the sine curve is all real numbers. So remember how we wrote that. You can write it with your real number symbol, or we would say from negative infinity to positive infinity. Our range is what we have for the y values. And our highest points at 1, our lowest points at -1. So we used to write that from the lowest to the highest, and we would put brackets because we include those points. Two new terms for us are amplitude and period. And amplitude kind of sounds like altitude, and that's pretty close to what it is. Altitude's like a height, right? A vertical distance. Amplitude, that's what it is. It's going to be the distance from the midline. So here's our midline to the maximum value. So this is our amplitude. I'm going to abbreviate it up there with amp. And like I said, it's the distance from the midline to the max or the min. So for our graph up there, the amplitude is 1. The other important measure that we use is the period of the graph, and that's just how long before the graph repeats. Another way to think about it is the cycle. So on our graph up top, one cycle repeats every 360 degrees, or 2 pi if we're talking about radians. And we can see that right here. It started at 0, 0, to the top, to the bottom, back to 0, 0. After that, we would have had the exact same thing over there. So this is 1 period in my magical rainbow pen. All right, so a lot of info there. I want you guys to try out the cosine yourselves here, right? We will do our t-chart by going around and taking the x values out and then graphing it on your graph. Remember, Google is also a helpful tool. I'll post our book pages from this section, or you can graph it on Desmos to make sure it looks okay, and I'll do a check for you. I'm going to just do maybe another video. I'll do these separate examples. This one's getting kind of long. So graph the cosine, fill out your t-chart, and we'll make sure everything looks good.